Hey Valley, welcome to the Chapter 10 review. Go over this stuff here and hit these targets, see if we can get you ready for the test. All right, starting off here, looking at this drawing here, you'll notice that I've labeled all the angles with letters. I'm just going to point out that I could label these angles also like this. I'm just going to put some points on here. We practice both ways in class, so I want to make sure you're ready for it. I could call this A, B, and C, and I'm going to give a point over here. I'm going to call it D. Just want to let you know that I could call this angle right here, I could call that angle A, B, C. I'd write it like this, angle A, B, C, and that would be an obtuse angle. I could call this little acute angle here, I could call it DBC. Call that angle DBC. I'm starting to repeat myself like Sal Khan, just a little bit here. And you can reverse the order of those letters too. You could call it angle CBA. You could call this one backwards, CBD, angle CBD. So just look, be aware that you can call different angles, lots of different names for angles. Sometimes I'll just make one more angle here. You could just call that angle 1 if that's what it's listed as. So here in this example here, I've listed these angles with letters. Okay, so first of all, it says name an acute angle. There's several acute angles here. This one's acute, so we got A, G, F. I'm just going to label these out. A, G, F. I think there's another one here. C is also an acute angle. Okay. And the next question, name an obtuse angle. Again, an acute angle is anything less than 90 degrees, and these are all less than 90 degrees. All right. Okay, name an obtuse angle. Well, the obtuse angles are going to be these larger ones here. They're greater than 90. So angle B, of course, is obtuse. And then angle D is also obtuse. We have got, I think those are the only two, because this angle here would be an right angle. And that's the next question. Name the right angle. That would be angle E. So on a test, you'd want to put angle A. You'd put this little angle symbol in front of all of those two, just to let people know what you're talking about. I'm going to grab another colored pen here. Hang on. Get the whole barrage here so I'm all set. Okay, because we're going to write over the top of this a few times. So the next thing they want to know here is they want to know what vertical angles are. So vertical angles are those angles that are across from one another. Like these two angles here are across from one another, B and D. So angles B and D, these are vertical. And then these angles here are across from one another. Sometimes we call them opposite angles. So A and C. So angles A and angles C. You can write them a couple of different ways here. But these here would be vertical angles. Okay. Now adjacent angles, I'm going to go to yet another color. Adjacent angles are any of the angles that are next to each other that share a vertice. Like this is the best example right here. G and F, they share a line and they share a vertex down here. Okay? So G and F, that's the best example of adjacent angles. So G and F are adjacent angles. Okay, but these angles up here, they share a vertex here. A and B, so A and B, these are adjacent angles, and B and C and D and A, all of those are adjacent angles. They're all next to each other. They're all neighbors, adjacent angles. All right, now name a pair of angles that are supplementary. Remember, I call it supplementary because it's the big meal. Any of these that add up to be 180 degrees then are supplementary. So like A and B, B and C, C and D, D and A. Because even D and A, these two angles add up to be 180 degrees. So I could write some of those down. I'll just put down a couple. A and B add up to be 180. B and C, C and D, and then D and A. Okay, some little slash marks in there, so those are all different sets. Okay, name a pair of angles that are complementary. Complementary is like that cheesy little snack you get in the airplane, the peanuts and the watered down Coke. it's not enough to fill you up. Complementary, it's not the full 180, it's just 90 degrees. Just a snack. These ones right up here, these here would be complementary. They add up to be 90 degrees, G and F. Okay? I don't think there's any other complementary ones on there. All right. Now we're down here to good old 10-point exclamation point. That should be 10.1b. So find the measure of angles formed by intersecting lines. All right, so let's see. What is the measure of angle 1? Well, here's angle 1 over here, and I'll put that in blue or purple or whatever this is. Well, we know that, I'm going to grab my other pen here, grab my red here. We know that this entire angle here is 180 degrees because that's a straight line. So if this angle here is a right angle, and we have that similar, if that's 90 degrees, you know, angle 1 has to be 90 degrees too. It shares that vertex. I mean, they're supplementary angles, okay? 90 degrees. So angle 1 is 90 degrees. That's pretty simple. What is the measure of angle 2? All right, so now we're looking over here at angle 2. Well, these two angles here, this 40 degrees and angle 2 will have to add up to be 180 degrees. So this one has to be 140 degrees because, again, they make a straight line, these supplementary angles. So 40 degrees and 140 degrees. They add up to be 180. So angle 2 is going to be 140 degrees. What is the measure of angle 3? Well, these here, remember from up top here, these are vertical angles. So if this is 40 degrees, this is 40 degrees. That's a simple one. Those opposite angles will be equal. And then angle, what is the measure of angle 4? Well, if this one is 140 here, this one too also has to be 140 degrees. It's the law of the West. I don't know why I said that. Okay, moving on to 10.4b. Let me just scroll up here. See, you can see that where I put 140 degrees there too. Sorry about that. I ran out of the screen there. We'll get the rest of the page on this one here. All right, so now we got 10.4a triangles. Triangle A. So we have to classify. Remember, classifying triangles is like Super America. We talk about the sides and we talk about the angles. So when we look at this triangle here, we look at the sides, I can see two little tick marks here that tells me these two sides are the same. So a triangle with two sides that are the same, that's called an isosceles. Isosceles. So it's an isosceles triangle. And let's see, well, now we have to look at the angles. We talked about the sides, the angles. Well, this is an obtuse angle, and then I've got these two acute angles. So we're going to call this an obtuse isosceles because it has that one obtuse angle in there. So it's an isosceles and it's obtuse. So classifying triangle B over here, well, let's look at the sides first. That this is one measure, one tick here, two ticks here, three ticks here. That means all three sides are different. So this, of course, is a scalene triangle because the three sides are different. And let's take a look at the angles. Well, we've got a 25-degree angle here. We've got a 110-degree angle here. And then we've got an unknown angle there. But we have this one obtuse angle. So this is a scalene and obtuse. Or you can call it an obtuse and scalene. But that's how we've classified that by both sides and angles. All right, now we have to find some missing angles here. What is the measure of angles D and E in this triangle A? So these two here, whenever you have two sides that are the same, two sides that are the same, two angles that are the same. And we can figure that out because we know that there are 180 degrees in every triangle. And if we take and subtract that 120 degrees, we only have 60 degrees left. And both of these angles are going to have to be the same because both of their sides, the legs of that triangle, are the same. So if we take and divide 60 by 2, we'll find out that both of these are 30 degrees. Those magic numbers, 180 degrees and 360. We're constantly using those numbers. All right, so what did I have? Let's see, D and E. So those are both 30 degrees, those angles are. And then what's the measure of the missing angle on triangle B? Well, if this guy here, and this is triangle B over here, so we have 360 degrees, and we have to take away 110, and we take away 25 degrees. Sorry, I'm going to change that. This is 180 degrees in the triangle. And we're going to subtract 110, and we're going to subtract 25 degrees. Sorry about that. I was thinking about getting my calculator out, making sure you can see that. So I'll just pop that into the calculator. 180, and we're going to take away 110, and we're going to take away 25. That equals 45 degrees. So this angle here has to be a 45-degree angle. And that looks right. It looks like an acute angle, about half of a 90. So a 90 degree like right here. Yeah, 45 degrees. Okay, let's move on. All right. Make sure we can get this on the page for you. I think I can. I think I got to make it a little bit smaller. Sorry about that, folks. All right, so I've got to be able to see pretty much the whole page. So we need to classify shape D. Now, we can classify that by sides and angles too. When we look at it, all the sides are different and all the angles are different. This is just a four-sided polygon. It's just a quadrilateral. I'm just going to write down quad because I'm lazy. Now we have to classify quadrilateral B. So looking up it here, well, we can see that we've got these two lines here that are both parallel. That's AB, and it looks like CD. They're kind of hard to read, but those two lines are parallel. So with only one set of parallel lines, exactly one set of parallel lines in a trapezoid, or in a quadrilateral, this is a trap. So we're going to classify it as a trapezoid. Now we also can look and see that it has a 90-degree angle in there. So we can say that this is actually a right trapezoid if we want to get really fancy, classified by sides and angles. All right, what's the measure of angles D and C in this one up here? All right, so we got to find out what C, which is over here, and D is. Well, this guy here is 120 degrees. So we know that this guy over here, this one here is going to be a 90-degree angle because this guy over here is a 90-degree angle. And again, these two angles over here are going to add up to be, 180, and these guys over here are going to add up to be 180. So this guy has to be 60 degrees. And I can just run a quick thing. I can go, well, here's 180 degrees here, and here's 180 degrees here. I could have gone 360 minus 120 minus 90 minus 90 and gotten the 60 that way too. I'll write that down. When in doubt, just subtract them out. Okie dokie. All right. Sounds good. Looks good. All right. The next one. What's the measure of angle D and C? I got that one. I got to put those down. Sorry. So D equals 60 degrees and C equals 90 degrees. All right. Next question. We run out here. Yep. I got to scroll up a little. Actually, I'm just going to have to make it a little bit smaller for you folks. Make it a little bit bigger there. All right. So it says, what is the measure of angle X in quad D? So now we've got to find this measure right here. Well, I'm just going to do the 360 thing. Take 360, and I'm going to minus 100. I'm going to minus 60. I'm going to take away 95, and that's going to give me my answer. So I'll just pop that in the old calculator here. 360, take away 100. I'm going to take away 60, and I'm going to take away 95. That equals 105. And does that look right? Yeah, it does. All right. You can double check it too. This is 160. And this is 95. And this is 105. And start adding things up too. Okay, there's my 105 already in the calculator. I'm going to add 95 to that. And I'm going to add 160. And I'm back at my 360. Okay? Try to check your work. Make sure you don't miss anything easy. So angle X up here was 105 degrees. 105 degrees. All right, what is the measure of angle Y in quad B? Well, where's Y? Y is up here in quad B. Y, I don't know. All right, so let's figure it out. This looks like this is a 51-degree angle. 51 degrees. Make sure you can read that. Looks good. So if this one is 51 degrees, then this one is 51 degrees. And I know that, these two angles here together you know, this angle and this angle will have to add up to be 180. So I'm just going to just clear this out. I'm just say 180 minus 51, that equals 129. So this would be 129 degrees, and this would be 129 degrees. The opposite angles in this parallelogram will be equal. I just double check that. Take 129 times 2, that equals 258. Then I'm going to add 51 and add 51. Make sure I got back to that 360 degrees. That's you need. Okay? Flip around here. Make sure we're doing okay. Time-wise, yeah, we're doing pretty good. All right, couple more questions. So this one here is 129 degrees. All right. What is x in quad 3? I'm going to make this a little bit bigger so you can see what I do here. All right. This one here is like the Old West. You got to round up the x's. Well, we don't have any measures here. We just have x's. But if we look at this, we have 3 x's here and 3 x's here. So that's 3 plus 3, that's 6 x's. Plus we have these 2 x's. So here's 3, 6, 7, 8. We have a total of 8 x's, and I bet you know that that's going to equal 360 degrees. Every one of those x's put together will add up to be 360 degrees. So I'm just going to take 360. This is a single variable equation. I'm going to divide by 8. Of course, they cross off on this side, and x equals 360 divided by 8, which is 45 degrees. Now, x is 45 degrees. That means that this guy right here, this angle here is 45 degrees, and this angle here is 45 degrees. But this one here is 3 times x, which is 3 times 45. You can pop that in, times 3, you get is 135, sorry about that. That's the worst looking 3 I've ever seen, 135. So these ones here are 135 degrees. Okay? All right. What is x in quad 3? And I just found all the other angles too while we're at it. Okay? Sounds good. Gather up those x's. You'll be using that in class several times by the time you get to this page anyway. All right, let me roll down here, straighten it off. All right, now this is our last target. 10.8a, decomposing polygons. I'm going to go ahead and write this formula down that we've been using in class. The sum of the angles is equal to 180 times the number of sides minus 2. This is the sum of the angles in interior, sum of the angles of the interior of a polygon, okay? A simple polygon or a regular polygon. And this n stands for the number of sides. That'll be right on your MCA test booklet in the inside cover. All right, so it says we got 2 polygons here. What is the sum of the interior angles of polygon A? So I'm going to count the sides. 1, 2, 3, 4, 5, 6, 7, 8. I got a total of 8 sides here. So I'm going to apply the formula. The sum is equal to 180. And I'm going to take that n. N is the number of sides, so 8 minus 2. Okay, I can simplify that. The sum is equal to 180 times 6. 8 minus 2 is. Pop that bad boy in. 180. Sorry, not times. Times 6. 1080. Looks good. So the total sum is 1080 degrees. I'll write it down here too. Equals 1080 degrees. All right, what is the sum of the interior angles of polygon A? The sum is 1080 degrees. All right, I could have, I'm just going to draw over this, I could have broken that down into triangles too. Some of you like doing that. That way you just choose one vertex and see how many triangles you can make by connecting it to other vertexes. There's 1, 2, 3, 4, 5. Now if I count my triangles, 1, 2, 3, 4, 5, 6. It's still 6 times 180. Okay? Just to show you that connection. All right, on this one here, what is the sum of the interior angles of polygon B? I'll do this one a little faster. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I got 9 minus 2 is 7. So I'm going to take 7 times that 180. That's going to equal 7 times the 180 degrees is equal to 1260. So the total sum of the interior degrees of this one is 1260. Okay? All right. What is the sum of the interior? I'll put these in. 1080 degrees. This is 1260. Okay, what is the measure of each angle in polygon B? Yikes. Well, this is a regular polygon. I've labeled it up there. So if there's 1260 degrees in that regular polygon, it's going to be the same for each angle. Remember, we had 1, 2, 3, 4, 5, 6, 7, 8, and 9. We had a total of 9 angles. So if we divide that by each of those 9 angles, and I can just, my calculator's still there, I just divide by 9, we're going to get 140 degrees for each of these interior angles. I can't do it on this polygon here because these angles are all different. It's not a regular polygon. All right, what is the sum of the measure of the interior angles of a regular polygon? Oh, this is no picture. It's a regular polygon with 12 sides. Well, if it has 12 sides, and I use that formula, the sum equals, 180 times the number of sides minus 2. I can just substitute that in. This is, this is 10 because there's 12 minus 2. So 180 times that, I'm going to move that up here. So 12 minus 2 is 10. And we're going to take that times the 180. It's pretty simple if you think about it. 10 times 180, you got 1800 degrees. Okay? It's the same temperature as a motel room I had once in Cleveland. Sorry. What is the sum of the measure of the interior angles of a regular polygon with 12 sides? The sum is 1800 degrees. All right, what is the formula for finding the sum of the interior angles of a convex polygon, of a simple convex polygon? I'm going to write it again. The sum is equal to 180 times the number of sides minus 2. Okay? Simplest way to do it, think about a triangle. 180 times, there's 3 sides in a triangle, minus 2, 180 times 1 equals 180. All right? Thanks for listening. Good luck on the test. Have a good evening.